Okay, let's get started. Thank you all for coming to JAM356. We're going to be talking about the new BlackBerry 10 browser application. My name is Eli Fidler. I'm the architect of the web technologies team at BlackBerry. I'm responsible for WebKit and the browser and the web runtime. And I want to give you an overview and also some in-depth information about how we built the new BlackBerry 10 browser. So we're going to talk about the browser itself a little bit as an application and do some screenshots of various pieces that I think are interesting. And hopefully my demos will work. And then I'm going to go inside the browser and talk about the pieces that make up all of the stack that the browser is built on top of, and how the BlackBerry web platform was useful for building an application entirely using HTML, JavaScript, and CSS, and ways that we integrated with the platform in order to make the browser a first-class BlackBerry 10 application, the same kind of thing that a built-for-BlackBerry application would do. And at the end, I want to talk about some of the lessons that we learned building the browser and some of the things that we are going to do in the near future. So this is the BlackBerry 10 browser. Hopefully, you have all had some opportunity to use it, either on the dev alpha, through the many updates that we've pushed out and the many evolutions of completely rebuilding this thing over and over again. And if you haven't, hopefully you will very shortly get an opportunity. We have been getting great reviews from all of the users who've looked at it. It's generally one of the best reviewed parts of the platform, so I'm very happy about that. And in case it wasn't entirely clear, we did announce this last year, but the browser itself has no native code in it. It is entirely built in HTML, JavaScript, CSS, and SVG. So here you can see some of the main content pieces of the browser. The first screenshot is what the browser looks like when you're just looking at a web page. You can see, oh, here we go. The browser Chrome is here at the bottom, and everything else, all the other pixels, are owned by the web page itself. And our goal here was to get out of the way as much as possible, give you the basic navigation that you need, bring the core BlackBerry 10 paradigms, things like tabs and the action bar and overflow, but allow the web content to own as much of the screen as we could possibly manage. You can see some core paradigms like the action overflow menu. That's what this second screenshot is, and that lets you take the web content that you're looking at and pass it to the device integration layer so that it will interact with the rest of the platform through the share framework. As well, it provides some core browser functionality. The third picture here, this is the tab switcher. So this is, again, a core BlackBerry 10 UI component, and it allows you to switch between different tabs and get to bookmarks and history. This is the main settings page in the fourth screenshot. And this is, again, all built with web, but this is the exact same UI specification as any Cascades application that you might build. And here's an example of one of the settings pages. This is the display. And you can see that there are some controls on here that are not generally familiar to web developers. So you can see there's this box up here. Click on the box expands, it pushes the content down below it. This is not a paradigm you generally find on a web page. And so we had to bring this to web content, but in a BlackBerry way. And you can also see the toggle switches here. The toggle switches are actually one of the most complicated core UI paradigms that we have in terms of implementation and the different animations and moments of charm in it. And again, not something that you find in the HTML5 forms specification or anything like that. So this is another piece that we brought to the browser application that you wouldn't find in a standard web page. So first, I just want to show you a live demo. This is BlackBerry Z10, and I've loaded a few web pages here in case the Wi-Fi is not cooperating. This is the BBC's mobile site. So in general, we work closely with all the top content providers to make sure that they are sending us a version of their website that is optimized for mobile, and that works really well in a handheld experience. And the BBC is sending us this version of their mobile page right now. And You can see, hopefully, we will be able to load things. The interaction is very nice. It's a very fast website. They've stripped out a lot of the extra content that they have on their desktop site, so a lot of the ads and that sort of thing, to make a nice mobile experience. Apparently my Wi-Fi is flaky. This is The Guardian. And The Guardian, again, is sending us their mobile site. You can see that it's a very content-based experience, and because we've given most of the pixels over to their web content, that they own basically the entire experience here, which is something that web content developers have asked us for. And it's just a vertically scrolling list. This is a Dutch newspaper, and I had to get some local content. I'm hoping none of these articles are too controversial because I don't speak any Dutch. And again, a very mobile-focused experience, which works very nicely. This is a nicely responsive site, actually. So hopefully I can switch devices here. This is the Dev Alpha C. And you can see, oh. All right, guess we're not doing any demos on this device. That's okay. Go back to this one. So this is that tab menu that you saw before. You can see that the interaction is very smooth. All the browser animations are taking advantage of hardware acceleration and CSS animations. Basically, all of them will run at 60 frames per second. You can see that it has peak. So peak is when I put my finger on the action bar here, and I can pull it over. Hopefully, you can all see that while I'm holding it, if that is more explanatory there. And the browser tries to follow all the core UI paradigms. Here's that overflow menu that we saw. It gives you all of the site actions. And here is an application list menu. So this is just a standard BlackBerry 10 list with the standard UI controls. Here's those toggle buttons. Switch back, maybe. There we go. OK, so how do we build this? This is what the stack looks like. At the bottom, we have our BlackBerry 10 operating system based on QNX. It provides all of the system services and the BlackBerry 10 framework, things like the invocation framework, that allows us to access other applications and background services on the devices. Then on top of that, we have WebKit. WebKit is an open source web rendering engine. It's written in C++. So most of the people on our team who have web in their jobs are actually C++ developers working on WebKit. And this is a big open source project. It's the rendering engine behind basically all of the popular mobile browsers and most of the desktop browsers out there today, including Chrome and Safari. And us at BlackBerry are one of the biggest contributors to this project. On top of that, we have the BlackBerry 10 web platform. And the web platform is a framework for running web code. So it itself has some native code and some web code. It's the executable that runs when you run the browser or a WebWorks application. And generally, this is behind the scenes, and you would never care about it, although you certainly have access to get into the web platform for building your own applications. And then the browser application on top, all JavaScript, HTML, CSS, SVG, just a web app. So this is the web platform. It is the foundation of everything that uses web on the device, including WebWorks and the browser. It's also the foundation for our QNX car. So you've probably seen BlackBerry integration, QNX integration into cars. We've done lots of showcases and demos, and they like to take expensive cars and rip them apart and put the next version of QNX Car 2 in them to demo. All the user interface components for QNX Car are built in web, just like the browser, just like a WebWorks application. It's a multi-process launcher, so the web platform will isolate web views from each other so that they can't have big performance impacts on the browser Chrome if you're loading a web page that has JavaScript that runs really inefficiently or something like that, or you're running some WebGL. The browser application still keeps running as fast as it can because we isolate the processes. It handles management of web views and native API access. So we talk a lot about native API access for WebWorks applications. This is how you take your JavaScript and you access BBM or PIM or the sharing framework, any of those sort of things. And all of those APIs are exposed up through the web platform. So here's some examples. And it also provides some of the BlackBerry 10 user interface elements. So I talked about some that are not common to web content, things like the toggle switch or the sheets. And those are actually written in CSS in your actual application code. But things like dialogues or the peek gesture, anytime you're managing screens, all of that is done on the web platform for you. So if you build a WebWorks application and you run some JavaScript, and the JavaScript calls alert, the dialogue that pops up, you don't have to write. It's provided for you, looks like BlackBerry 10, and it's provided by the web platform. And it is also written in web. The web view is the primary API that's provided by the web platform. So when you run web content, let's say in a WebWorks application or in the browser, it runs in a web view. You can think of it kind of like a browser tab. Every browser tab has its own web view. And there are two main kinds of web views. There are what we call Chrome web views. Chrome web views are special. And in the browser, the Chrome web views are the ones that actually run the browser code itself. So not code that you've taken from the internet and put in a browser tab. Those are content web views. This is code that we've written, we think is safe, and so it gets special access to some APIs. So in particular, it gets access to the WebView API. So when the browser wants to create a new tab, it creates a new web view and loads some web content into that web view. That API access is restricted. It provides a native API plugin that allows you to get access to the invocation framework directly and that sort of thing. And it relaxes some of the constraints of the web runtime. So the W3C, the standardization body for HTML5 and most of the other web technologies that you are used to, specifies security properties of the web runtime that are generally applicable to web views that are loading arbitrary, untrusted content from the internet. For local applications, including WebWorks, we relax some of these restrictions. So for instance, you can get file system access to the actual file system of the device. The HTML5 file system API, as specified, only has access to a special sandbox that site has access to. It's not a general get me to my root of my file system on my device API. And then content web views also have some special optimizations. So they have a backing store. The backing store allows you to scroll and zoom content very efficiently. It decouples scrolling and zooming from the actual page rendering. And because this is arbitrary content that can be arbitrarily difficult to render, we make sure that the high-performance rendering happens in the content web views. The browser application doesn't really zoom. The Chrome doesn't zoom. And scrolling is generally one-dimensional. So we don't need the large backing store. It also has a disk cache. So the browser Chrome web views don't have a disk cache. We don't load content from the network to actually draw the UI components. So we don't enable the disk cache in the browser. So this is what the browser looks like. There's a browser tab. Those of you who were in my last session have already seen this, but I'm very proud of this slide. And this is Wikipedia. You can see it's running on top of the browser Chrome. Here's the tab menu. I just showed you this interaction live. But in the background, I actually have 3 tabs here. They each have their own web view. And you can see I've now exposed the rest of the browser Chrome. There's a title bar at the top. The title bar goes away so that all of the pixels on the screen can be given out, or all the pixels except the navigation bar can be given to the site. And so those are also all in separate web views. So all the browser is basically 6 web views. Some of them are content web views, some of them are Chrome web views. Each of them has a web page in them, an index.html file, basically. But there's no special native component that's making all of these things work together. So we have web versions of all the BlackBerry 10 UI. They are all using HTML, CSS, JavaScript, SVG, and images. And we also have baked into those all of the transitions and animations that are part of the core controls. So when you saw when I touched the toggle, the halo animates up and back, and that's implemented using a CSS transition. It's all rendered on the GPU, so it's hardware accelerated, and that is the absolute key to making a lot of these things fast on mobile, is to make sure that you're taking advantage of the GPU as much as possible. We try to make the runtime do that for you, but certainly this is a very common thing on web content on all mobile devices. Everybody hopefully knows that you should use CSS transitions to do basically all common animations, and that's because they generally get hardware accelerated. We do have window animations to cover some additional cases that are not standard web use cases, things like taking one web view and sliding it off another web view, like we do with the tab switcher, but those are generally minimal. And almost everything is a CSS transition. So here's some example of the UI components. The first one there, that's the site information dialog, and this is the dialog that you would get if you called confirm, basically, from JavaScript. So you get the icon, you get the styling, you get the gradient titles, you get the buttons, you get the fade out of everything in the background. That is all baked into the web platform for you. Then we have sheets. So the second one is a sheet there. This is what happens when you hit more info on the site information dialog, and it slides in. And this is just added to the application stack. You can peek it. Why don't I show it, because rather than waving my hands around. I don't have any secure sites loaded on here, so let's pull up. Bank of America. Sorry. I know it's not a good European test case, but. So you can see this Bank of America has a lock icon here. This is an EV cert, an extended validation cert on an HTTPS page. So if I pull up the site info here, you can see that it has information saying this is the Bank of America Corporation site, and this dialog is just a standard web dialog. I hit more info, and the sheet slides in from the side, and this is, again, just another web page. And then the settings screen and the display and actions settings screen, you've already seen examples of. And then the last one there, that is what we call the crosscut menu, which is the context menu. If you long press on content inside a web page, this menu comes in on top. This is another component that's provided by the web platform. So if you're building a WebWorks application, you get this dialog for free. And it's your hook to get system integration with context. So if you want to take a link in a web page, long press on it and share that link, share framework integration is done through the context menu. We'll talk about that a little bit more later. So inside the browser application, we have our web launcher. It's a native C++ executable that provides some native APIs and runs web containers. It creates a web view. The web view has its index.html. The web views, the Chrome web views that have special API access, have a special JavaScript API called QNX.callExtension method. And that establishes a JavaScript to native binding. So this is how you get out to native APIs. Then the Chrome web view uses a QNX.callExtension method call to create a new web view. And that web view is where we put the tab bar. The tab bar is in a separate web view from the main Chrome. And those communicate over an RPC channel. And all of that stuff lives in the Chrome process. So this is the browser applications process. Then we create a content process. And the content process gets another web view created by the Chrome web view, and that's where we load our tabs. So here we're loading BlackBerry.com into a tab, we're loading Starbucks.com into a tab, whatever. And we can load more of those, and those are in a separate process from the browser application. So if anything malicious happened in those, somebody tried to hack my browser, or there was some sort of vulnerability in WebKit, and they crashed the tab, the browser application would keep running. It's in a separate process. It's running controlled content. And you would get basically a page that says that the browser tab has crashed, and you can restart it, or you can just get rid of it, and the application keeps running. So this is both a security and a reliability feature to isolate arbitrary web content that's coming from a server that we don't trust from trusted content that we're running in its own process. So here's an example of using the WebView API. We will be going through some code here, but not too much. There's lots of samples and the WebWorks samples about how to use most of these APIs. So here, the key things here are that we've created a unix.weblauncher.webview, and it has lots of settings like enabling Web Inspector. This is our debugging and profiling and development tooling. And then on the WebView, there are lots of asynchronous APIs. So this is a very JavaScript-y API. All of our APIs are written in such a way to be familiar with the ways that web developers are used to using APIs. So there's a lot of on-event and asynchronous calls. There's almost no synchronous APIs at all. So you get a callback when your WebView is created. We created it here asynchronously. And then when it is created, we set some properties on it. We call load URL. And in this particular case, it's taking some command line arguments and opens that URL. So this is actually the main loop of the web launcher application, the JavaScript part that implements it. All of the browser itself is in a modular architecture. So we've taken every piece of it that we reasonably could and put it inside a plugin or a module using a pretty standard web container format. We use require.js as our module loader. So for those of you who've built large web applications, this will sound familiar. Basically, you make a closure with an object with all of your methods that you want to expose, and then you set that as your exports in your module. And you can load your module asynchronously later. And here, this is the progress bar. So it has a create progress bar, and that calls some things that I'll get to in a second. So we have our JavaScript here. We have our HTML here. So every module has some JavaScript and some HTML and possibly some CSS as well. This is a very, very simple DOM. It has an HTML and a div, and that's it. And what this does is it passes a reference to the div, this one in particular, into the create progress bar function. And the create progress bar function creates some additional DOM, appends it, and sets the classes so that your DOM ends up looking like this. And this is the way that all of our modules are built, is they find a hook into the DOM, and they replace that, place it hooked into with some more DOM and some JavaScript and some styling to implement whatever control it is. So in this particular case, it's progress bar, but the toggle button is the same, or even something as complicated as a sheet with an action bar and content in it and all of this sort of stuff is a very, very similar concept. And this is pretty familiar, I would think, to people who've used most of the modern web frameworks. So the browser is hopefully an example of a full BlackBerry 10 built for BlackBerry application. It is, like I've said many times, entirely built in web technologies, but all of the key components of a built for BlackBerry app are present in the browser. So that is, it's integrated, it's social, and it's beautiful. I'll give you some examples. So system integration, the browser is an invocation target. So in addition to be able to invoke out of the browser, you can invoke to the browser. If you're in an application and somebody has a HTTP URL link in their application, and you hit it, and their application doesn't handle links internally, the invocation framework will invoke the browser. So this is how the browser is an invocation target. This is part of the manifest file that you build whenever you're building any application. So some of the tooling will build your manifest file for you, but you can also do it yourself. It's just an XML file. And this is how you make an invocation target. So the browser is an application. It has an icon. So this icon shows up in the list of invocation targets of the other application when you open a URL. So it says, do you want to open this in the browser? And that's the icon. It supports open. It supports these different protocols. So these different protocols for the URIs and every MIME type. And it filters on these MIME types for non-URI invocations. So these are for file invocations. It can open these type of files off the file system. So it is easy to build a WebWorks application that is also an invocation target. It registers with the invocation framework to handle whatever MIME type or protocol scheme your application can handle. And this is what happens when you actually get invoked. So here you can see our require module. We have Iris is the super secret, don't tell anybody code name of the browser. And it has an eventing framework. So here we have an asynchronous event. It's invocation.invoked, and it calls this invoked function. And so here we have some more require modules. We have a tab controller that handles all of the different browser tabs. We have the invocation framework. We have the eventing framework again here. And then if you get a request that has a URI, then if that URI has a supported scheme, so these are the protocol schemes that we support, then we create a tab. I've stripped out a bunch of code here for if like that is already open in a tab or something. But we create a new tab, and we pass the URL, and that tab will now open. This is all asynchronous JavaScript event routing. So, simplified code example, but certainly not too much. And there are code samples for you to do this in your own applications if you want to build something that can handle invocations. Here's another example of a different sort of invocation. This is implicit NFC invocations. So this is a simplified version of the code that handles if you have your browser and somebody else takes another NFC-enabled device and you just touch them together and they happen to be looking at a web page, that web page will open in your browser. So when that happens, you get an NDEF push event. This comes from the native NFC framework. So WebWorks and the web platform provides a binding to the native NFC framework. And you will get a callback on this, or you get an event that goes to this callback. And then this allows you to share your tabs. So I have some function called should share tab. I don't share like super secret private tabs, but if it's just a regular tab, I'll share it. And then this is that special QNX.callExtension method API that I talked about being bound into the Chrome. So it can send a call to push NDEF message and with the tab URL that I want to send and with the title of that tab. And that will go through the NFC framework and send your tab. One other thing that I wanted to talk about here. You can see at the bottom here, hopefully, it says event.on browser.init.tier3. The browser is built to launch as fast as we could make it launch. And hopefully it will always be getting faster. But the way we did that is we split our application invocation into multiple tiers. And I'll talk about this a little bit more later. But functionality that is critical to you starting to interact with the browser happens in tier 1. So when tier 1 is done, you can use the browser. And then functionality that's critical to loading content from the web and creating that second content process so that you can interact with a website, that's tier 2. And then tier 3 is all other browser functionality. So we do make sure that everything is loaded at launch time of the browser. So if you wanted to do an NFC share or something, you wouldn't have to wait for it to load content. But we make sure that it's not on the critical path to getting the application up as fast as possible. And this is really important for getting your apps to launch as fast as possible and making them usable and deferring things that you don't need right away, but you still want ready if the user is going to use them later. So like I said, I'll talk about this a little bit more later. Notifications. So there is an HTML5 notification API standardized by the W3C. And we've integrated that notification API into the system notification framework. So this is an example of where we've taken a standardized API, but on BlackBerry, that gets bound into platform functionality automatically for you. So if you registered for notifications and the site calls the standard HTML5 notification API, then after a permission dialog, but whether the site is allowed to send notifications, the browser will send that notification to the notification service. This is a system service. It will appear in your hub. If you press on that notification, the browser will get an invocation. It will get notified that that notification was acknowledged, and then it will fire all the standard W3C notification API callbacks. So the interaction goes out of the browser. It goes through the hub, but it's all the standard HTML5 APIs. And you don't have to do anything special to get that hub integration. System protocol support is another level of system integration. So for these 3 protocols in particular, tel, SMS, and mail to, what the browser does is if the user activates a link through either clicking on a link or an XML HTTP request to one of these protocols, then it will know that these are unsupported protocols. The browser itself doesn't handle tel links or SMS links. So it will actually ask for permission to access the system handlers. So if you click on a tel link, for instance, it will pop up a dialog saying, do you want to call this number? And if the user says yes, so that permission asking is in the browser, or in the web platform, actually. If you say yes, it will just send an invocation request to the invocation framework for you. So if you want your application to be able to load, a WebWorks application to be able to load web content, or even a Cascades application with a web view, and that web content has a tel link in it, and you want it so that when the user clicks on the tel link, it invokes the dialer, that is handled for you automatically. So you don't have to do anything special there. Another example is menu service integration. So for these protocols, we obviously have things like the contacts. So if you want to mail to some email address, that email address may have a contact associated with it that has more information, like that person's real name. Then if you activate the context menu on such a link, we go behind the scenes and ask the menu service, which is part of the invocation framework, to get the information for this contact. So if you long press on a tel link, for instance, in addition to open link and all of the normal things you would get on a link, you also get things like add to contacts, because you can add telephone numbers to contacts. Or you'll get call the person, the name of the person who has the contact associated with the telephone number. So all of that integration with the system is done behind the scenes for you. Social, our second theme. The browser has a couple of different ways of integrating with social networking. The first is through sharing of web content. And there's two ways of sharing web content. There is page actions, that is sharing the page that I am looking at right now. And that is done through the overflow menu. That's the bottom right button on the action bar. And it has share, and then you can share the current page's URL and title with any of the share targets that are registered on your device. So with Facebook or LinkedIn or Twitter or whatever. The second is contextual actions. So if instead of sharing the page that I'm looking at, I want to share a link or an image or a selected piece of text, I'll show you a demo of that, then I activate the crosscut menu, the context menu, and now the share targets will be the ones that are registered to handle those types. So rather than something that's registered to handle a URL, it can be something that's registered to handle a piece of text, which could be a different set of share targets. And hooking up the kind of thing that is the context right now and the targets that are registered to handle that type is done behind the scenes for you, so you don't have to do anything special. Let's see if I can get HTML here. There we go. OK, so here's our website again. Let's say I select some text. So there we go. And I'll get the context menu. And I share. And now, if I say shared this with NFC, let's do. And then, oh, I forgot I can't demo this device. Well, that's not going to be very interesting. So I can share that with, say, BBM. And I'll send that to Blanky. So there's the word that I had in my text selection. And I can send that to BBM. And the last theme was beautiful. So the BlackBerry Flow, the standard way of accessing different pieces of the system without going in and out of applications, is also a core part of the browser. These are two examples of where I'm in the middle of a peek. So in the first case, I'm peeking from a browser tab to the tab switcher menu. And this follows your finger. It allows you to see the current content and other content that you have loaded without leaving the application. And the second one there, this is a share target selector. So in this particular case, I've taken a page, and I've shared the URL of that page as a text message. And so on the right side there, it says compose at the top. That's the text message composer, and the text message composer, and then I peeked it over to the side. So The text message composer is now, for all intents and purposes, in the browser app. I didn't leave the browser app. The text message composer is a Cascades app. So I have two different runtimes running here. They're running in different processes. They're different parts of the system. But it looks and it feels to the user like this is one application. This is about more BlackBerry 10 UI components. So we've talked about the structure of the browser, things like sheets and the settings page. Those are high-level application UI components. What we've also done is we took some of the small core components, things like buttons and checkboxes and radio buttons and some of the pickers and that sort of things, and we actually brought them into the web content that we're viewing. So if I have a web page, this is a test case I happen to have that shows you a number of the HTML5 forms controls here. All of the little control editing, or the control visuals here, are close to the BlackBerry 10 versions of those controls. So there's some things about being in web pages that is different from the context about being in an application specifically designed for those controls. And we've had to make some compromises to not break the web. But in general, like the buttons look like BlackBerry buttons, and the pickers, so these are examples of 3 of the pickers. So if I have an input type equals color, HTML5 input type equals color, you get a button that has the current color. It looks like a BlackBerry button. If you click on it, you get this pop-up. And it has a slider view to select the color and a swatches view to select predefined colors. And this color picker dialog is provided for you by the web platform. So if you want to have an HTML5 color picker in your WebWorks application, you don't have to do any special work. But it looks like a BlackBerry dialog. It has the standard buttons and look and feel of a BlackBerry dialog. It grays out the page behind it. All of the and the animation to open it and all of that is the standard platform behavior. The second one, this is a select dialog. So this is this one here. You can see it looks like a combo box. Press it, and you get this pop-up screen. And it scrolls, and it looks like the Cascades control. But again, this is all implemented in web, and you don't have to do it yourself. The third one here is interesting. This is the file. So here I have an input type equals file. I click choose files, and I get this screen. This screen comes in as a sheet, and you can see I can get to different places on my device. And it has its own action bar, so this is a full screen control, not a dialog, because that's what the platform file picker looks like. This file picker is a Cascades application. Now, you wouldn't know that, and you don't really care that. The browser integrates across runtimes for you. And then when you pick your file, it says the name of that file here, like most file pickers do on the web. So all of this integration is automatic. And it adapts. So I have some examples here of the browser running in an English locale and the browser running in an Arabic locale. So for those of you who've tried to build web content for internationalized purposes, either through applications or even just for websites, you know that some of this stuff is very difficult. And the browser pretty much just takes advantage of what web standards provides in internationalization. So it has a couple of special things for translations, but in terms of left to right versus right to left layout, it uses all web standards. So for those of you who've done this before, it's doing exactly the same thing that the web standards do. So in particular, you'll notice things like the assets have switched. So here, our back button is an image that looks like a left arrow, and here it's an image that looks like a right arrow because we're in a right to left locale. And like the icons are on the left side of the image list, and here they're on the right side of the image list. And all of the text is left aligned, and here all of the text is right aligned. All of these changes are implemented by just putting a dir equals RTL attribute on the container. So you didn't have to do anything special, and it automatically adapted for you. You can see another example over here. These, unfortunately, I didn't get into exactly the same state, but internationalizing the toggle buttons and the whole left to right versus right to left flow of the entire sheet, and putting the components of the combo boxes in the appropriate places is all done automatically for you. You can see it did the asset switch as well here. And so that's all done automatically.
Except for the BBC page, which is done in Arabic.
So some web pages, we are telling the web page that the current system locale is Arabic, and the web page does what it wants. So in this particular BBC mobile page, they decided not to adapt to the locale of the current device. That's probably because I had accessed the page before, and so it just cached that I was using it in English. But some websites would have sent you a different site. That's up to the content developer. It also adapts for different resolutions. So these are some screenshots. Unfortunately, I can only show you screenshots of the browser running on the Q10. So you can see this is a square display, 720 by 720, different resolution. And in this particular case, I'm showing Google Maps. And it has the overflow menu. You can see the overflow menu is cut off at the top here. So the overflow menu bottom aligns on both platforms, and it scrolls. The sizes of the list items and that sort of thing, the text sizes, is all automatically adapted for you. It is slightly different between the Z10 and the Q10, but the web platform takes care of that for you. You can see here's the Guardian. And one feature I didn't show on the Z10 is reader mode. So this is an article on the Guardian with their desktop layout. And then in the overflow menu, there's a reader button, and that gives you this kind of view where we strip out everything but the main content. And it gives you just a vertically scrolling view of it. It has a text sizing control, and that's it. So it's a very simple experience. And reader mode is particularly nice on the smaller screen because you can see this is giving us the desktop site. So it has a lot of content, often with very small fonts, and reader mode handles that nicely for us. So the web as an application platform we think is totally viable, obviously. We built what we think is a great-looking, high-performance application on top of this web framework, and we think that people building WebWorks apps can do just as good a job. How you implement performance-sensitive functionality is important. So sometimes people spin web as an application platform as easy, or it's a way of taking content that you've already made and just automatically getting everything nicely packaged up as an application. And that's true. You can take web content that you've designed and package it up as an application and run it in a different container format very easily. But that doesn't magically make web content that isn't optimized on the browser environment optimized in the application environment. So you have to make sure that you're building good content. It's just like any other application platform. If you're building a native application, you can build it efficiently or you can build it inefficiently. And that's true of web as well. So we have lots of code samples, and we have lots of help available from our web evangelism team on how to build efficiently for mobile. And it's not that this is so difficult, but using things like CSS transitions to do your animations rather than having a JavaScript loop that moves things around is starting to become more common knowledge in the web development community. But we still see a lot of content out there, especially on sites, that isn't efficiently built. And so taking those site contents and packaging them up as an app doesn't make it a great app. It makes it an OK app. We think that there are still some gaps in the open web platform. So I've mentioned a couple of things that we've done that are BlackBerry proprietary. We have some custom meta tags and a couple of attributes and that sort of thing. But we're actively working on getting those standardized. And the pace of the open web platform, the pace of the standardization efforts and all of those sort of things, despite what everybody says, is amazing. The kind of things that you can do on competing platforms, you can do on iOS Safari, or you can do on Chrome for Android that didn't work 6 months ago is amazing. And you know, the BlackBerry platform is first in standards support, and we will continue to keep it that way. And so things are becoming possible across all of the runtimes. And that is one of the key parts of using web technologies to build applications, is that most of the work to build the core of your application, you can do once for all platforms. That doesn't mean write once, run everywhere, but it means that the hard stuff you can do once. Making your app, making the content, making the core interactions, you can do once. So performance is always feature number one. Performance is always the thing that people say differentiate native apps or differentiate top apps or the best apps. Performance is always number one. So I talked about tiered loading. Tiered loading is something that took our browser startup time from 7 seconds to about 600 milliseconds. Now it's a little bit faster than that. So this is order of magnitude type improvements. And the kind of things that we need to do to get the application up and running so you can type in a URL or you can go to your bookmarks is only a small subset of everything the browser does. So when you're building an application, try to identify those core things that you really need to do before the user can start using the application, and do only those things before the user can start using your application. Scrolling frame rates is another common place where people have mentioned that the web may be behind native as a application development platform. So the performance of scrolling through a list, for instance, is a common test case to see if a web platform is good enough to build native-looking apps. And there are some ways of, there are a number of different ways of doing scrolling of web content. And we think that native scrolling is like the only obvious choice, but there are certainly different opinions on that. Native scrolling is generally achieved by having a container that has overflow scroll or overflow auto set on it in the CSS. And then you add this property, WebKit overflow scrolling touch. This is a property that was introduced by Apple in Safari 5, I believe, for iOS. And what we use this property for is to tell the engine that this is going to be something we want to native scroll. So that gets you native kinetics, and it gets you native performance. Sure.
Do you use tiling as well for scrolling?
OK, so the question was, do we use tiling for scrolling? I talked about the differences between content web views and Chrome web views, and one of the things about content web views was the backing store. So the backing store is tiled, and what that means is that it can pre-render content that isn't on screen if we think you're about to put it on screen. So if you're scrolling in that direction or that sort of thing. And we do that all behind the scenes for you. So to some extent, you have to tile for limitations of the GPU and that sort of thing. But any native scrolling will use the backing store, so it will be tiled. There are some web toolkits that try to use JavaScript-based scrolling. You may have heard of iScroll or lots of other frameworks for doing this. They definitely have their places. They allow you to have common kinetics for your scrolling across different platforms and that sort of thing, or make faster scrolling on platforms that didn't support accelerated native scrolling. This is generally older platforms, especially old Android. And personally, I think the days of JavaScript scrolling frameworks have passed, because every browser is making native scrolling faster, and nobody is making JavaScript scrolling faster. JavaScript is already pretty fast, but rendering has a limit. So if you're building something that has to scroll in web technologies, use native scrolling. And then if you have to run it on Android 2.2, make a separate fallback that uses JavaScript scrolling. Because native scrolling is the future and the now on BlackBerry. So we talked about CSS animations and transitions. Asynchronous loading, I talked about the way that we've packaged everything up as require modules, is extremely helpful. We couldn't have built our tiered loading without asynchronous loading of modules. And also lazy loading, so that is defer things until you need them, or defer things until you have spare time to load them. And remember that the web is mostly single-threaded. So there's some great presentations out there on how browsers work internally, how WebKit and Gecko and all of the other engines are built. But fundamentally, to implement the standards, most of the things that you have to do in the expensive parts of your application must happen on the same thread. So that is generally rendering, parsing, JavaScript execution. Those have to happen on the same thread in order to support web standards. So that means if you build a website that has extremely expensive JavaScript, like you have a JavaScript that will run for a long period of time and just churn out the next piece of data that you're going to add to your screen, that will block rendering. So we defer, or we separate things like scrolling and zooming. Those we can do even if the main web thread is busy. But at the end of the day, I'm going to need new pixels at some point, and those are dependent on parsing. So if you're passing large amounts of JavaScript or large amounts of CSS or large amounts of HTML, those have to happen synchronously, and JavaScript execution. And the tooling around web is generally pretty fragmented, but Web Inspector This is the Chrome developer tools are also based on Web Inspector, but we have Remote Web Inspector, and we've been shipping it since Playbook. Is an awesome tool. And basically all of the developers who built the browser application have one of their browser windows open on Inspector all the time. Like, this is useful for debugging. It's useful for just visualizing what's going on, for profiling, for auditing the current state of your application, all of these things. Inspector is the best tooling out there to do this. And we think we have the best mobile remote web inspector of any platform. And it's very easy to get to. We expose it over all of the network interfaces that your device has. So you can connect over Wi-Fi, you can connect over USB net. That's my personal favorite. And use your desktop or your laptop to do all the application development live. You can change CSS, you can change DOM, you can set breakpoints in JavaScript live. So definitely recommend Web Inspector tooling. And what are we doing next? So we want everybody to develop web applications that are as good as the browser. And so that's why we have talks like this, and we tell you what we did, and we put out code samples and that sort of thing. It's because we want web applications to be awesome. So the technology that is inside the browser, some of it is already part of WebWorks. More of it will be coming to WebWorks. So when you're building a WebWorks application, you will be able to get access to these APIs nicely packaged up for you without having to write any extra code. And we're constantly working on WebKit. We have a reasonably large team that's one of the biggest contributors to WebKit, and making sure that standard support is always improving and performance is always improving. And by contributing these changes back to WebKit, we make sure that all the WebKit ports, Safari and Chrome and Qt port and all of these other things, are getting the improvements so that when you start building your web content using the new web technologies, they work in all of these different platforms. And as the open web platform evolves, more things will become fast, more things will become native, more things will become hardware accelerated across all the platforms. So definitely we're seeing that the next generation, the latest generation of all of the browsers are a huge step ahead of the previous generation, and things that people are doing now, things like native scrolling, WebKit overflow scrolling touch, works everywhere. So there is definitely progress. I know everybody is sad that the W3C doesn't run quite as fast as we would like, but consensus is there, and the platform is moving forward. So thank you. I think I have a little bit of time left for questions. Yes, I do. I have about 7 minutes. So we have a question in the front here.
Just if you could repeat, will be coming to WebWorks, the technology? I thought WebWorks was based on the...
So the browser is not currently a WebWorks app.
Okay, just the web view is...
But the web platform powers WebWorks apps, and it powers the browser. And so we built a lot of this technology as part of the browser and are pushing it down into the web platform so that WebWorks gets it. So things that I've said are part of the web platform. Things like dialogues and cross-cut menu and all of that stuff were built for the browser and then now are available in WebWorks. And so what we're trying to do is package up all the pieces of the browser that are not about being a browser and make them all available to WebWorks.
What about the web workers?
Web workers. So for those of you who are not familiar with web workers, they are a standard API for running JavaScript on another thread. They are actually implemented as a system thread, so you can run JavaScript without running into this single-threaded web problem, without blocking web rendering. We support web workers fully, and the question was about shared web workers as well. We do support shared web workers, and they work great if you have to do background processing and your logic is built in JavaScript. So if you're trying to do some image processing from a canvas or something, you can send that data off to a web worker and have it go in the background, and it won't interrupt the flow of your user interface. And then send back the data when you're ready. The web is basically asynchronous. Everybody who programs in JavaScript and has been doing it for a while builds almost everything asynchronously, and web workers are a fully asynchronous API. So definitely recommend using web workers. Yep.
What are the frame rates you support in request animation frame?
So the question was, what frame rates do we support in request animation frame? Request animation frame is a JavaScript API that you call when you want the browser to tell you to render the next frame of your animation. So rather than you just setting a timer and saying, I'm going to render every 10 milliseconds or 16 milliseconds or whatever, You just say request animation frame, and the browser will call your callback and say, give me the next frame. So request animation frame is actually adaptive, and it will make sure that you're not rendering too often. So if you have something that can render at 200 frames per second, but we're only running the display at 60, we won't waste your battery life. And it also makes sure that the frames of the animation are synchronized. And so if you're rendering something that we can render fast enough, we will call request animation frame at 60 frames per second.
But the dev alpha, like, was not giving that. I don't know about the actual device.
OK, so the question was about request animation frame on the dev alpha A. The dev alpha A had significantly worse rendering performance than either the dev alpha B or the actual Z10 shipping device. So if you've done some JavaScript-based animations and done testing on the dev alpha A, I recommend that you test again on either the dev alpha B or on the Z10. The dev alpha B and the Z10 have the same GPU, so performance is similar, although there's always tweaks. Yeah, in the corner there.
What offline storage is available? What would you recommend?
So the question was about offline storage. We support basically all of the offline storage APIs that are supported by any of the top platforms. So that is things like local storage are the easiest ones to use. We also support WebSQL and IndexedDB, and then related things like app cache. So all of those are supported on BlackBerry 10, and it's hard for me to recommend one without knowing anything about what you're doing, but certainly they are all viable for different use cases. The one thing about WebSQL is that it is officially deprecated as a standard. So it's supported on iOS, but only iOS and BlackBerry 10 for mobile platforms. I think we have PPK, you would know. But if you're trying to build something that will work on any of the Android platforms or into the future, I would recommend avoiding WebSQL. And there are some nice shims that people have built in JavaScript that can provide one API on top of the other, although providing WebSQL on top of IndexedDB is probably not the most efficient thing to do. But you probably don't really need a SQL-based query language. Yep.
We have around 1,000 applications developed native and hybrid. And for the hybrid application, about 10% are now done in HTML5 and wrapped over the full gap.
Mm-hmm.
Why we should go with WebWorks, why we should not use for what we are doing further, because you already have the Android iOS hybrid application in HTML5, why we should have WebWorks there? Why will it be not enough only to have the HTML5 and the wrapper for the phone?
Okay, so the question was about why use WebWorks. If we already have an application that's using HTML5 and that's a hybrid application on other platforms, why do we need WebWorks? And the answer is, if you don't need WebWorks, you don't need WebWorks. So WebWorks provides two things. WebWorks provides a packaging tool chain for web content. So you can take some purely HTML, JavaScript, and CSS and produce an app. If you're building a hybrid app, you need to write native code. So if you're OK with writing native code, then that part of WebWorks is not important to you. The second thing that WebWorks does is it provides pre-built APIs written in JavaScript, or written in native, bound into JavaScript. So you can write JavaScript code to get to BBM. And the way that those calls happen is through WebWorks. Now, you could write this yourself, but WebWorks has already done a lot of the work for you. So the two main pieces, packaging and API access, if they are useful to you, WebWorks is an excellent way to do that. If they're not useful to you, then that's fine. Now, one thing to say also is that WebWorks is a very similar piece of technology and is based on some very similar things to Apache Cordova, which is also known as PhoneGap. So if you're already using PhoneGap or Cordova, you're basically already using WebWorks. Like, historically, WebWorks has been the BlackBerry stack in PhoneGap. And we're actively working to bring those projects closer together.
Is there any difference between the performance in BBUI.js and the native JavaScript? Now is it?
The question was, is there any difference in performance between BBUI and native? And I don't really know how to answer that question. I mean, there's always a difference in performance between anything that you do. I wouldn't necessarily say either is faster or slower in all situations, but certainly you can build an application that is fast enough to render at 60 FPS for reasonable UIs in either of those technologies.
Well, a couple of things. The first one is that we mentioned the difference of performance with the Deb Alpha and the Deb Beta. Is that because the Deb Alpha uses an HGX544 as a GPU, which is a tile-based defer rendering engine. The thing is that what I've seen in plenty of browsers in the architecture is that when the compositor gets the layers out of the web views and uploads the textures to the GPU, that uses a native pixmap. And then the problem is that we do it, and it ends up being a GL text sub image 2D, and we end up calling the texture that it's already on the
I think
GPU.
we should probably talk about this one offline.
Well, well, I had a couple questions as well. Is the GL sandboxed? All the GL is sandboxed, and then
Okay, so the question is GL sandboxed? Are you talking about WebGL?
no, the GL calls that. Well, the GLES calls that.
Okay, so in general, I mean, I showed you the sandboxing architecture. All content is sandboxed. All interactions with WebKit that come from content from untrusted sources is sandboxed from WebKit instances that have access to special APIs.
So you use like graphics context and.
So there is already protection there for malicious WebGL or malicious web content of any kind.
Do you have hardware accelerated canvas now?
Question is, do we have hardware accelerated canvas? We've had hardware accelerated canvas since Playbook 2.0. Okay, I think we're probably out of time. Yep, we're over time. Okay, thank you very much.